Hi guys, so today in this video we will write a Java program to find the roots of a quadratic equation. So first of all let me save this as, let us say, roots quadratic, so roots quad.java. So let us save it first, roots quad or quadratic and then .java, the extension. Now let us start writing the source code. So first of all we will make the public class roots quad, the name same as the file name, so roots quad, and then inside the public static void main we will write the, or we will get the variables or the coefficients of the quadratic equation from the user, and then we will check the determinant's value and then give the roots as the output. So we have written the public static void main string args. Now first of all we have to declare the variables for the coefficient, so let me just write it down. So we have to insert values of coefficient. So we will write double a comma b comma c and semicolon ax square plus bx plus c and the coefficients a, b and c. So now what we'll do is we will also declare roots. So double root 1 and root 2, root 1 comma root 2, and then we will insert the value from the user. So I have to use the scanner, so I will import java.util. So let us import it first. Import java.util.star. So and then we will have the scanner's object as scanner sc equals to new scanner, and in the parameters I will write system.in. So new scanner and then system.in and then semicolon. We have to see for the capital and small letters, so here I wrote small s in place of capital. It would have given me an error, so let us proceed ahead. Now we have to get the coefficient. So first of all we have to give the user command like enter this coefficient or another one. So let us write system.out.println enter a, and then we will write a equals to sc, the object of the scanner, dot next int, means the string that was inserted from the user will be converted to int and will be stored inside the a. So let us copy paste this whole thing, and then we have to do the same for b and for c also, because we are having three coefficients of the quadratic equation ax square plus bx plus c. So b equals to sc dot next int, and then for c also we have to do the same. So after inserting the coefficients we have to first of all have the value of the determinant. So let us write it down in the comment that we got the values of the coefficient, and then we will have the value of determinant and then print the roots. So we got the coefficients of the equation ax square plus bx plus c. So of the equation ax square plus bx plus c, and now what will we do is we will check the value of determinant. So let me just write it down also. So now we will check the value of determinant and print roots. So and print roots. So let us declare a variable for determinant as d only. So double d would be equal to b square minus 4ac. So let us write it down, b star b for b square and minus 4ac. So 4 star a star c. And then we have to check the condition. If it is greater than 0, then equation would be having real and distinct roots. So let us write it down only. So first of all we have to write the root 1 and root 2. So root 1 would be equal to minus b plus square root of the determinant upon 2a. And for the square root we will use the method sqrt, but we will write it as math.sqrt. So minus b plus math.sqrt of determinant. So sqrt of determinant, and then this whole value upon 2a. So let me close the bracket. Now divide by 2a. So divide by 2 star a. Okay. Now let us copy this part for the root 2 also, because root 2 would be equal to minus b minus square root of determinant upon 2a. So let us change this plus to minus now. So now we have to give the formatted output. So we will use system.out.format, and we will write it as root 1 equals to %2f and root 2 equals to %2f, and we will write root 1 and root 2 after the printing line. So system.out. Let us say format to have a formatted output. So let me just write it in comment so that you won't get confused with system.out.println. So we have to get formatted output, that's why we are using this. And then let us write root 1 equals to %2f and root 2 equals to %2f. So let us write it down. So root 1 equals to %2f and root 2 equals to %2f. And then after this we have to write r1 and r2. No, we declared it as root 1 and root 2 only, so we will write that variable only. Now we have to check the second condition, if d or determinant was equal to 0. So we will write else if determinant double equals to 0. We will copy paste this whole section and then edit this part. So if d was equal to 0, we are not using single equals to, because single equals to will assign the 0 value to d, but double equals to means it is comparing. So for determinant equals to 0, r1 and r2 would be equal, and it would be directly minus b by 2a because determinant's value is 0. So we have to get the formatted output. So I will directly write root 1 equals to root 2 equals to %2f, and then only give one variable so that only one value is printed. So let us remove this root 2 variable. Okay, now if determinant was equal to 0, then root 1 and root 2 would be equal and it is printed. So if it is not greater than 0, if it is not equal to 0, then it would be less than 0, and then the roots would be containing a real part and an imaginary part. First root would be real plus imaginary, and second root would be real minus imaginary. So if determinant value is less than 0, then we have to write real and imaginary value also. So we will proceed ahead. Root would contain a complex number and a real number. So contain a real and an imaginary number, that is a complex number, and complex number is a number which is a negative value but under a root. So we can't compute that, that's why it is called as an imaginary number. So complex number, let me write it down only, negative value under root. So let us proceed ahead. So double real would be equal to minus b upon 2a, because the determinant's value for the real part would be 0. So let us directly write minus b upon 2a. So 2 star a and then semicolon. And then imaginary would be double imaginary equals to square root of minus d upon 2a. So let me just copy paste from the above part. So over here we wrote it already. So let us just copy paste. Now in the square root it was having minus d. So we will input negative value over here. Okay, so we have to print the value now. That is, first root would be real plus imaginary and second would be real minus imaginary. So let us just copy paste this part. Okay, so root 1 equals to %2f plus %2f, means plus would be printed on the screen and you would see real plus imaginary as an output. So let us complete this and write real comma imaginary, so that this variable's value would be printed in place of %2f and %2f. So let me just copy paste this part, and root 2 would be equal to minus, real minus imaginary. So we will check for errors later. Let us first of all remove this and compile this. So let us go to file manager now. This may contain errors like we wrote system.out.println small s in place of capital. So in command prompt we have to compile this, so we will change the directory first of all. So cd change directory, and my program is in coding and Java programs, so I will write the file location. Now enter. Now first of all I have to compile this. So java c roots cod dot java program, and then okay, so I mistakenly wrote equals to after curly braces and double real equals to minus b upon 2a. So let us go ahead, let us check it out. So it was over here. So in else part I wrote curly bracket open and then equals to, and over here let me just give a bracket so that it won't give an error. So let me just close it. Okay, so let us compile this again. So let us go to command prompt now. So over here I will write java c roots code dot java. So I wrote system.out.format. So in place of system as in capital S, I wrote small s. So let us correct it out first. So let us go ahead and correct our mistake. So capital S over here also, over here too, and then afterwards in both of these. So now it should not give me an error. So java c root. So now it compiled with 0 errors. Now let us run this java and then program name. So let us enter AS12, BS20, and then CS13, and root should be minus 0.83 plus 0.62, and another would be minus 0.83 minus 0.62. So let us check it out. So 12, 20 and 13, it will give my determinant less than 0. So here was the root for this equation. Now what I will do is I will print this as root 2. We mistakenly wrote root 1 over here, and then slash n for the new line. Okay, now let us write the same equation again, that is 12x squared plus 20x plus 13. So let us write it again. So root 1 and root 2 was printed on different lines. So let us run this again, and then we will write a small value, that is 2x squared plus 4x plus 2. So the determinant would be equal to 0. So we got root 1 and root 2 equals to minus 1. So let us go ahead and write the input as 100x square plus 1000x plus 2, so that we will get different roots. So let us go ahead and then see as 2 only. So we got root 1 as minus 0.002 and root 2 as minus 9.998. So here was a small program. Let me just show you the program again. So if you want to take the screenshot of the whole program, you can take one over here. We declare 3 variables for the user to get values into, and then we compare the determinant with 0 if it was greater than 0. Then real and distinct root. If it was equal to 0, then root 1 and root 2 would be equal, and then if the determinant's value was less than 0, then the roots would be containing a real value and an imaginary value. So thank you guys for watching the video, and do like, share and subscribe. Also comment down below if you are having any doubts. Also suggest me any programs you want me to make video on.